Okay, guys, let's begin a session for today. I'll share my screen. My screen visible?
Yes, we can see this.
Okay, perfect. So, our session for today is based on load balancers. As I mentioned in the last class, load balancers are used to decrease the load on your instances or systems. So there are two types of load balancers which we're going to study today. That is the network load balancer and HTTP or HTTPS load balancer. So I'll just give you a quick difference between these two. So network load balancer supports only within a region, whereas in HTTP load balancer it supports cross region as well. Uh, NL we'll say network load balancer as NLB. Further on, NLB is based on IP address, port, and protocol type. Any TCP or UDP traffic, even SMTP can be load balanced. So it handles these four protocols: IP address protocol, port, TCP UDP, and this protocol traffic. Whereas HTTP load balancer only deals with HTTP and HTTPS protocols. In the case of packet inspection, it is possible, and load balancing is based on packets in the case of network load balancing, whereas HTTP load balancer cannot inspect the packets. The workflow basically is that in the case of network load balancer, forwarding rules is the starting point. It directs the request to the target pools from which compute engines will pick the request. So the workflow is like forwarding rules to the target pool and then to the instances. In the case of HTTP, it is quite complex as global forwarding rules routes direct the request to the target HTTP proxy, which in turn checks the URL map to determine appropriate services. These services in turn direct the request to the instance group. So workflow is like global forward starts with the global forwarding rules. It'll go to target HTTP proxy, which in turn goes to URL map, then to the backend service, and then finally to the instance group. In the case of health check, it is optional in the case of network load balancer, but network load balancer relies on HTTP health check for determining instance health. And health check can be verified by either using HTTP health check or HTTPS health check in the case of HTTP and load balancer. This is just like an overview, and we'll create both a network load balancer and an HTTP load balancer in today's lab. So start. Is everyone on the same page? I'll as well. Okay, perfect. Let's start with today's lab. Once again, I suggest you to use the incognito mode because there should not be any clash with other account. Activate the cloud. Okay, so we're first making the network load balancer. So in that we will create instances. So whenever there is a request, network request, and we'll add the instances in a group so that whenever there is a network request, the instance which has the least traffic or least burden will respond to the request. So, but as in the case of network load balancer, as a we can only balance the load in the same region. So first step would be to setting a default region and a zone. Okay, so we for me the zone is US West 3. We'll set that. We even did this during the Kubernetes zone when making a cluster. Set the default region and zone. Now we create multiple instances and add them in a group. So we can go to the compute engine section and or even create through the uh, cloud shell. So when creating through the cloud shell, this will be our command. Instance create ww1 for name of the first instance. Zone is the zone which we have set. Tags, we need this tag because all the instances in one group, so we'll use tags to do so. Machine type is the type of the machine. Image family is the type of the OS image. Image project is the Debian Cloud. We're naming the project Debian Cloud. Then this is the command which will run when instances run. So we'll make it to route the traffic. It's just a name that are different ww1, ww2, and ww. Time minutes. Second is done too. And finally, our third instance. Okay, so all the three instances are running. We can check this. So see, we created three instances. All of them are in the running state. We have their internal Hello, am I audible?
Yes, you're audible.
If you made your instances, please type in the chat box. If you haven't or you're facing any problems, please mention that too. Perfect. So now we'll create a group for our instances. This command is we'll use to check the list. And CURL is a command which will verify the instance if it's running or not. We'll check for one instance. Uh, when we add the instances in a group, we can define a firewall rule for the entire group. We don't need machine every
Mhm.
single time. Oh, I missed that step. Okay, so we need to allow the traffic and see. We are making a firewall rule for the LB tag. Remember, we tagged the we have given tag to our machines. So this firewall rule will apply to all the machines which have this tag. So now we can check. See, this was the Linux command which we had given while creating our machine. S3 web server and the name of the instance. Our instances are running. Now it's time for us to configure the load balancing service. That is to make the network load balancer. So firstly, we'll create an static external IP address for the load balancer for it to route the packets. So we are creating the network LB, the name, and we're mentioning the name and the region, that is, and the region will be the same because we can route only in the same region in the case of network load balancer. So we've created. Our next step would be to add a health check. This is just to see if the load balancer is still functioning properly or not. This is not compulsory, but it is better to do so. We're creating a basic health check. It will just keep on pinging the load balancer in the background, and if there is an error, if the ping is not successful, then it will give us a message. Now we'll create a target pool where we will add our instances so that the packets keep on transferring from one instance to the other and there's not more load on a single instance. We'll create a pool. The name of the pool will be www pool in the same region and we'll add our health check to the pool. After creating the pool, we will add all our instances like www1, www2 and www3 to the pool. Target pool is the name of we'll add the instances to www pool and the name of the instances. Okay, so our pool has been created, our instances has been added to the pool, and we've also added a basic health check to the pool. Now, we just need to create a forwarding rule. Forwarding rule is just the main the starting point of a load balancer, as it will forward the traffic of a of one instance to the other instance so that there's not more load on a single machine. So region is our US West 3. We are using TCP the protocol. So we're going to use port 80 for this. Network LBIPI is the name of uh, our the group which we have created for the instances, and the target pool is the pool of the instances. This is the tag. So this will be the starting point of the load balancer. From here, all the traffic will be routed to the instances. We will see the working live. Okay. So our forwarding rule has also been created. We'll check the progress. So now our load balance, our instances have been created. They've been added to a pool. We've created a load balancer. We've created target pool, added instances to it, and even configured a load balancing service. Now all we need to do is forward traffic to the instances and see the working of the load balancer. So we will make this rule in the same region to add traffic to the instances. Even this should be in the same region and the port should be 80. Now we will access the external IP address. This is just to show the user the IP addresses. And finally, we'll view it. That this is the IP address of the static IP address of the load balancer. And now with this command, what it will do is show you the IP addresses that keep on changing based on the instance which is being used. This is an infinite loop. See, for some time it will show you the instance 1 and the other times it will show you 3 and the rest of the time it will show you 3. So it keeps on changing based on the traffic load so that overloading of a traffic on a single instance can be avoided. This is all done on the backend, so we are not able to see when we're using a website or other services. Is everyone clear with the network load balancer. Okay, perfect. So now we can stop this with Control C. Now our task is to create an HTTP load balancer, and for this we don't need to mention any specific zone or region because it is a cross region service. The first we need to create the load balancer for because we already created our instances so that all these steps can be avoided. uh Ishan, yes, it's almost similar to time division multiplexer, but it works on just the layer 3 or layer 5 of the network protocols. And it's not synchronized because it can work in a random order based on the load which a machine is having. So firstly, with the our network HTTP load balancer, it is kind of the same. All the commands are basically the same because we are just creating a load balancer and naming it backend template. The region for this balancer we need to define. Network will be default, subnet default, type of the machine, image family, and these are the commands which will run when we create our instance. We'll create a, we'll install this web server and restart the machine. We're creating a basic HTTP load balancer template, and now we'll manage our instance groups. The instance group which we're using from the previous network load balancer. This will only work with the HTTP and HTTPS protocols. Hence, it is cross region. Okay, base instance's name, instant template is also given. So now for this, we need to create a health check because without that, HTTP the load balancer does not work out, and we'll add it in the firewall rule. See here, the network is default because we do not want any particular zone region. So this is universal. This will allow external traffic on the machine through the port 80. Now our instances are running. We have we are yet to define a global static external IP address which we will use to reach the load balancing service. So we'll ask Google to provide us with an IP, and we will be given with the IP that is available on their service. It is stored in our variable. Now we'll create the health check. So our health check is also up and running. So you remember last when I was speaking about HTTP load balancer, I told you how the workflow is. So we created the forwarding rule, then there was health check, then we moved on to the backend service, then the URL. So now for the backend, we create a service which will help us route the HTTP protocols to different instances. We use the health check which we have created. Protocol is HTTP. So backend service is also up and running. Now a service has been created. So now we need to add our instance which was running to the service so that it will use the service to route the traffic. So we are using the name of the instance group which we created, LB backend group, which had three instances, WW1, 2, and 3. Now this instance group will use the backend service to route our traffic, HTTP traffic. So now our backend service is also created. Our next step is to go to the URL map. This URL map, which we are creating, has the name web main HTTP, and which is using the backend service which we created, web backend service. This will use the backend service to route. Even that is up and running. Now we need to use our HTTP proxy to route request to the URL map. The name is HTTP proxy and name of the map in the previous case which we created, web map HTTP. Even our web map is ready. Now we create the forwarding rule so that it forwards the traffic from that point, forwards in this case because we're not mentioned HTTPS, so it will only forward the HTTP traffic. So now we can check our HTTP load balancer should be made. Now finally, to check if our machine is routing properly or not, we will check using a browser. Now to get the go to load balancer in network services. We can just search for load balancer here. So you can see the HTTP load balancer has been created, and also we can see the previous network load balancer here, and it has one target pool with three instances and and the web map HTTP has one backend service with one instance group. So we'll click on the HTTP load balancer. Here we see its IP address with the port. We'll use that to see our how it's functioning. are healthy. Yeah, two of them are healthy. Okay. It takes some time in some cases. You can try adding the IP address of your load balancer, and you will see uh, the output of the machine, which the Apache server which we added to the machine. And if you refresh it a couple of times, you will see that the IP address is of another machine, which was not the case in the previous one. So it will keep on, the IP address will keep on changing based on the instance which is routing the packet. It gives an error sometimes, which is in my case. Yes, okay, so it's working in my case now. So you see, if we keep on refreshing it, the final address changes based on the machine it's forwarding it from. Did everyone create complete making the HTTP load balancer? Yes, even if you're not getting the output, please post it in the chat. Uh, the lab is basically done, so we can wait for some time to see if others are getting the output. Please mention in the chat if it's taking time so we can see what's taking time, and if there's an issue, we can help you resolving it. Guys, I also need to explain the next lab to you, so please type in the chat box if you are done with the HTTP load balancer or if you're facing any types of issues. Okay, thank you, Aman. So we're done with this lab. We can end this lab now. And so in the next lab, it is basically a revision of all the previous labs. So what I'll suggest is that you go through each lab before starting this lab. This is your homework lab. Here you'll be needed to create a VM instance with the name and the type which they will mention in the lab. Then create a Kubernetes cluster and finally a load HTTP load balancer. So you can just go through the previous labs and then perform this lab. You'll be given 1 hour. It's more than enough time. And after this, this quest will be completed. And from the next class onwards, we'll move to the next quest. Is that all right? Okay, perfect. We'll put it in the group when our next session is, and from now onwards, because we are through with the basic concepts, some of the labs you will have to do on your own, and the more tough ones or the ones which require professional assistance, I will conduct meetings like this. And if you're facing any issues in the other labs as well, you can drop a message on the group or even ask a question in our future meeting so that we can try and solve your doubts. And with that, we can conclude today's session. Thank you all for coming. And do try to do this lab as soon as possible. You'll get your quest completion badge. I'll stop the recording.